Yes, this is the same opening screen that we saw yesterday because we are continuing with section 1 of chapter 12 about classifying and naming. Today we're going to name some triangles. So first we need to make sure we understand this concept of interior and exterior. Remember, interior means inside and exterior means outside. Okay, now a lot of times you have to actually draw your side coming out so that you get that exterior. Okay, so write this down, whatever part of it you need to write down. Some of you are like, duh, Miss Amick, I knew that. And others of you are like, oh, it finally makes sense, which is fine, either way. So this theorem, remember a theorem is just a fancy geometry word for a rule, okay? Something that we know to be true every single time. And this one you should already know, okay? That the inside angles, the three angles inside a triangle, add up to be 180. So if you did x, 2x, and 3x, you could say that x plus 2x plus 3x equals 180, solve for x, which is what you'll be doing. Write this down, even if in your own words, even if you are like, I've known that for years. Write it down anyway, because it's weird how easily you forget this little fact that you right now you think is easy, but once we add other facts in there, you forget this one. For example, here's one that makes you forget the other one. Okay, so notice here we've extended this side, okay, to give us an outside angle or an exterior angle. Okay. So this theorem or rule, remember that's just a fancy word for rule, says that these two angles out way over here, if you add them up, they equal this one outside. There's lots of fancy words for all of that. It's the two non-adjacent interior angles. Some places you'll hear them called the remote interior angles. It's the two angles that don't touch the outside angle. Notice that this angle right here touches this angle, right? So it's the two angles that are farthest away from the outside angle that you're talking about. Pause this if you haven't already written it down, write it down, hit play, and we'll do an example. So here's your outside angle. Here are the two that are furthest away. And so we can set up an equation, 70 plus x equals that other one outside. So 70 plus x equals that one outside. And then solve for x. So we'll subtract x. 70 equals x minus 5. Add 5. Yes, you could have done that in a different order, of course. And so 75 equals x. And so now we know what x equals, but be careful because the question is actually asking for, JKM. So JKM. So it's actually asking for that outside angle. So we have to take our 75 and put it back in for x. So 2 times 75 minus 5. 2 times 75 is 150 minus 5. So 145 is our actual answer. So be careful what it's asking you for. Some of them will just ask for x, by the way. Okay. Let's try another one. So remember, we've got this outside angle here, which, by the way, is what it's asking for in the end. Okay. And we've got these two remote interior angles over here, the ones that are furthest away. And if we add up those two angles, 2x plus 65, it's going to equal that one out there. And then we just need to solve. Let's solve it differently this time. So negative x plus 65 equals 25. Subtract the 65. I'm going to move up here. Negative x equals negative 40. Can't have a negative x, so divide by negative 1, and x equals positive 40. But again, that's not what it asked for. So we got to take that 40 and put it in for our x here. I'm going to actually erase some stuff here. You can always back up if you need to. And so we've got 3 times 40 plus 25. 3 times 40 is 120 plus 25, so 145 degrees. Isn't that what this last one was? How funny. Oh well. So there you go. Okay, so a corollary is another fancy word that just means it's a rule that exists because of another rule. It's like a branch. Like you have a big rule, right? And then because of that rule, you've got these other little rules. And so a corollary is one of those little rules. Don't get bogged down in that vocabulary, corollary, theorem, all that stuff. What matters is the rule, and that is that the acute angles of a right triangle are complementary. Okay, let's talk about this. This makes sense. Okay, we know that all 3 angles in this triangle add up to 180, right? And if one of them is 90, so we take away that 90-degree angle, then the other 2 have to add up to 90. That's what this corollary is saying. Okay, so write it down. And then we're going to do this example right here. So we have a right triangle. We know that because it gives us a little right mark. Okay, and so we know that therefore those 2 angles add up to be 90. So we can do 2x plus x minus 6 equals 90. 3x minus 6 equals 90. 3x equals 96. Divide by 3, and x equals 32. But it says find the measure of each angle. So we need to put that back in there. So 2 times 32, this one would be 64 degrees. And 32 minus 6, this one would be 26 degrees. They add up to be 90, so that works. Okay? You don't have to remember that corollary, actually, ever. If you remember, which you need to remember, that all of the angles in a triangle add up to be 90. To be 180. So you could simply do 2x plus x minus 6, plus x minus 6 plus 90, plus that angle right there, equals 180, and do the same thing. Solve for x. Okay? So you don't technically have to remember this last corollary. As long as you remember that all 3 angles add up to be 180, you just have one extra step of subtracting that 90 out. Holler and Zoom if you have questions.